I guess we are on live. Hi, everyone. Welcome to the webinar. We'll be going through an interesting topic today. We are together with Bilal today. Welcome, Bilal. How are you?
Hello, everyone. I'm okay. Doreen, how about you?
Yeah, all good, all good. I'm always interested with such new topics that is arising around Kubernetes and cloud-native technologies. That's why we would like to go through the technology called KubeVirt today. And I hope the streaming and everything is okay. Inside the comments, please let us know if anything is missing, guys, okay? I would like to start with some questions. And if anyone has also experience, please let us know in the comment. And we will also go through some hands-on, let's say, experience as well. And we would like to hear about your also questions and experience if you have all. So first question, Bilal, what is KubeVirt?
Okay, we are starting directly, okay.
Yeah, directly, yeah. Very simple question. What is KubeVirt? What problem does it solve?
Okay, so this is a good question. This is a good question to start with. So KubeVirt is basically a add-on to Kubernetes. You can get this from the name. I mean, it's a add-on for the Kubernetes environment. So this add-on lets you run traditional virtual machines right alongside your containers within the same cluster. So this is basically what KubeVirt does. It's an add-on. It's help you to deploy your virtual machines inside of a Kubernetes cluster. And maybe we can talk about why they needed to create such add-on. So we can talk about the problem first. So the problem it solves is let's think about it. So your developers, so in an ideal world, everything will be containerized, right? So your developers will work on containers. Your infra team will create Kubernetes clusters or OpenShift clusters and deploy the containerized workloads to that cluster. But in reality, most of the customers I work with can't just containerize everything overnight. So they've got legacy applications, old Windows workloads, Oracle databases, and this type of stuff that has been running on VMs for years and nobody wants to touch it.
Okay, they have the VMs. They have still the VMs. Okay, we know it. Obviously, that's mostly for enterprise companies, but why there was a need to bring those VMs into Kubernetes instead of keeping them separate? We have already done keeping separate. Of course, there may be several reasons, not just technical, but I know because of VMware licensing changes recently, but that's another story. What was the technical need to bring into Kubernetes?
Yeah, so as you mentioned, this is a hot topic at the moment because of the license changing, but let's focus on the problem first. So before KubeVirt, you will end up managing two completely separate platforms. One for your VMs. It will be usually VMware or some other stuff. Like nowadays, I believe Proxmox is gaining some hype. And this is the first platform that you manage. The other platform will be one for your containers. So that's double the effort, double the cost. And also from the maintenance perspective, it's double the headache. So basically KubeVirt comes in and say, okay, just bring your VMs into the Kubernetes. You get one platform, one set of tools, and one API for everything. So it lets teams modernize at their own pace. So you still have your containers, you still have your VMs. You can modernize and containerize your VMs at your own pace. So without being forced to rewrite everything from scratch.
Okay, I guess it also has some organizational and changes in maybe not obligatory, but changes in the team structure, maybe, right? Because enterprise organizations sometimes have like teams for VMs separately, teams for Kubernetes workloads separately. So it's then also an opportunity to merge those teams, maybe, because their skill sets gets merged, right?
Exactly. So the main reason is operational simplicity. So when you keep your VMs and containers separate, you are basically running two different worlds. So as you said, it means that you need to have two different teams, two different tool sets, two different ways of doing things. So, and it gets messy really fast. So let's think about it. Your developers are already learning Kubernetes. They are writing YAML files. They are using kubectl. Now you are going to tell them that, okay, this is great. But for the other app, you need to go to the completely different platform and learn whole different tool set or workflow. And that's not fun for anyone. I mean, so, and this is the experience part. So when you think about the networking and storage side, and when your VMs and containers need to talk to each other, and they always do, because most of the customer I work with run their databases in the virtual machines. So applications, tier 2 applications need to connect to these databases. So you have your applications containerized, but the data store is still in VMware or virtual machines. So VMs and containers need to talk to each other. You end up building all these bridges between two platforms. So it's extremely, it's extra complexity and that nobody asked for. So just to summarize, by bringing VMs to the Kubernetes, you get a single control plane for everything. So same CI/CD pipelines, you will deploy your you will deploy your VMs as you do your containers. So it will be the same CI/CD pipeline, almost same YAML file, same monitoring system, same networking module. Your team doesn't have to context switch between these two platforms all day.
Okay, so we don't. Companies does not need to make two different investments in such case, right? Because what I'm hearing from you, they were doing two different investments for those tool sets, one for VMs, one for containers. But when we merge them into Kubernetes, some of those investments can be also merged. What I can hear from you, is that right? You think, or
yes, that's exactly true. Because I have never met a developer that can deploy. Sorry for the developers, don't get me wrong, but I have never met a developer that can deploy a virtual machine to the VMware. Okay, this needs a whole different thing to do. But since the developers now start learning Kubernetes and they know how to deploy a YAML file using the CI/CD technologies like Argo CDN, etc. So they will be able to deploy virtual machines as they do the containers. So it will be much more easier for them. So they will be using same environment, same CI/CD pipeline. So there won't be any difference in two different platforms.
Yeah, it sounds really interesting. I would really like to hear if anyone now listening us, if you have guys any of your problem that you think you can solve with KubeVirt, or any of your existing environment which you may think about to convert KubeVirt, please comment. Okay, we would really like to hear about your use cases also. And maybe I can ask, like, of course it's inside Kubernetes, but it has of course an architecture. So would you be able to maybe explain like a high level of architecture of KubeVirt, its components, maybe like launcher, controller, and also in simple terms, like how does it work? How does it allow VMs and containers like run side by side? If you can maybe would like to show any type of picture also. Yeah.
I'll share a picture directly from the KubeVirt website and try to explain it. Now, okay, let's share it. So, are you able to see it?
Yes.
That's good. Okay. So, KubeVirt is a great add-on, but how does it work in under the hood? Okay. So I believe most of us deployed custom resource controllers or CRDs to the Kubernetes before. So KubeVirt is almost the same. So in simple terms, KubeVirt basically extends Kubernetes by adding custom resource called virtual machine. So as you do deploy your pods using pod resource for the virtual machines, it will be virtual machine. So just like you define a pod in a YAML file, you define a VM in a YAML file. So Kubernetes doesn't natively know what a VM is, but KubeVirt, the add-on we deployed, teaches Kubernetes what VM is. So under the hood, what happens is each VM runs inside a pod. It's literally a pod. Inside that pod, there's a process that uses KVM and Camel and to spin up an actual virtual machine. So from Kubernetes perspective, it just sees a pod, but inside that pod, there's a full VM running with its own operating system and everything. And I mean, that's the beauty of it, because the VM lives inside a pod. So Kubernetes only see a pod. But the KubeVirt inside the Kubernetes cluster actually manages that VM. So it automatically gets all the Kubernetes goodies like networking, storage, scheduling, health checks, all of that just works. You can put a VM and a container on the same virtual network. They can talk to each other natively. No weird hacks needed, because this is another pain point that we face with the customers. They have their own traditional VMs, and they created bridges between these two networks. So with the help of KubeVirt, you will able to, so once you deploy a Kubernetes cluster, you will have a overlay network. Like it can be Cilium, Calico, or if you are using OpenShift, it will be OVNK. So this is the overlay network where your pods get an IP. So in order to make your containers to talk to the VM, you will need to extend that network. So, but with the help of KubeVirt, you can, like, since these VMs are a pod in the end, the virtual machines will have a IP from the overlay network. So in the end, your VM, your pod, inside the same overlay network, they can talk to each other without any hacky ways or needs.
So from what I understand, it is not like under the hoods, I mean, a new technology. It's already using Linux KVM, which is like a technology already exists in Linux. So like I remember the time back in Docker, when Docker first was in the market. It was not also new technology, but it combined different Linux kernel modules that day and packaged them and made and created Docker. And this is also what I can say is the technologies inside Linux kernel is used to create such technology. As far as I understood, is that right?
Yeah, exactly. In the backend, it's still used with KVM and Camel. It's not a new technology. This is the technology that most of the hypervisors uses. But the KubeVirt helps us to do it easily, like we do in the containers. Like you can create VMs, like you create pods. So this is the beauty of it.
Okay, nice. I mean, I'm really excited when I first hear this technology back maybe a couple of years back, and it's really amazing to see the progress of this. And I think maybe VMware also helps a bit to to progress. But my next question is, Bilal, so the key, I know the audience may have VMware already on their environment. So what do you think the key differences between KubeVirt and VMware? Of course, you have mentioned the mainly the architecture it's two different worlds, two different. It's not like a competitor to VMware, but what do you think the key differences are?
Okay, good question. So, KubeVirt is first of all the license. So KubeVirt is a open source project, and now you can go to the GitHub and you can see the actual code that's behind that KubeVirt, and you can deploy it without paying any commercial license. And since VMware is also solved the same problem, but it is a commercial product, so you need to pay. I don't know about the license model, but you need to pay per code that you are planning to run, deploy, or anything else. So the first key differences will be the pricing, of course.
Okay, but on VMware, what I hear from the industry or VMware admins, they always claim they already have an ongoing operations with VMware, ongoing like VM lifecycle operations. So what do you think, like those VM lifecycle operations, when they move to KubeVirt, how do they affect? Will they be able to do the similar operations with KubeVirt also?
Exactly. So basically, when we talk about lifecycle, let's talk about what we are doing while managing a virtual machine in VMware. So you provision it, and you assign an IP to it. You create a network for the VMs, and sometimes you need to, let's say, upgrade one of the worker nodes or the host platform. So you had to move your VMs to the another node, and deleting them, changing the cloud init files, and maybe from the security perspective, you need to also create a network policies between VMs and the other stuff. So these are the operations that comes to my mind when I think about the life cycle. So using KubeVirt, exactly, this is a good picture. So using KubeVirt, you will be able to do all of them. You can spin up a new VM using these virtctl commands, which we will do in a demo after this one. You can provision a VM, you can stop them, you can restart it. You can even migrate it. And if your Kubernetes environment and your worker node supports it, you can even live migrate your one VM from one bare metal node to the another one. So it's actually it's like running a pod, deploying a pod inside a Kubernetes cluster.
Yeah, thank you. As you said, like we have, let's say, similar KubeVirt also has functions that are required for, as you can see on the screen, right? Like stopping, deleting, and you mentioned also migration as well. So we have similar operations. Let's say if we compare to, of course, VMware operations, same requirement, but with different form, of course, right? So still we can, or the snapshot operations, cloning operations. So still we have similar operations that we get used to on VMware. I think those would be much more than enough, but still there may be questions like if VMware is still better, or if KubeVirt make more sense than VMware. You think in which scenarios, in which type of use cases KubeVirt make more sense than VMware?
So if you are already have a if you are already managing a Kubernetes cluster, and if you don't want to spend more money on licensing, if you want just to spin up some VMwares, and if you want to merge them together, I mean, KubeVirt is the perfect fit for you. So VMware is a standalone platform, and we should think like this. VMware is a whole different platform. It's a standalone platform, but KubeVirt is just a Kubernetes extension. VMware has its own ecosystem for everything. KubeVirt leverages what Kubernetes already provides. It doesn't come with a networking solution. It doesn't come with a storage solution. It just uses what Kubernetes provides. Like if you want to schedule a pod, on a worker node, it will be same for the VM also. So it's basically up to you. How do you manage your VMs and containers as of today? So if you want to merge them, I mean, there is no other way to do it without KubeVirt. So KubeVirt is the best fit.
Okay, thank you. And let's say, from what I understand, it's a hypervisor, an alternative. Let's say hypervisor. Is there any possibility to use it on AWS? Do you think it's a fit to use it on AWS, or it is only for on-prem environments? What do you think about this?
So you can both use KubeVirt on public cloud, on AWS, for example, or on-prem. So the only thing you need is a KVM or KEMO interface, which means that you need to do you need a bare metal work nodes for your Kubernetes cluster. So for example, we are currently working with a customer, and for example, on this picture. Now, in this picture, we are creating a EKS cluster. But if you see the node type, it is C5 metal, which means it is a bare metal instance. It also means that you can do hyper virtualization. Nested virtualization. What does it mean? So if you spin up a new EC2 instance in, let's say, T2 small or something like that, you will have a virtual machine. But if you spin up an EC2 instance with a node type C5 metal, you will get a bare metal EC2 instance. And using that instance, you can also deploy virtual machines on top of that. So you will get a nested virtualization. With the help of KubeVirt, you will be able to run your VMs deployed on an EKS cluster. So it is possible. You can do it on your AWS environment. The only thing you need is bare metal instances, which AWS provides.
Yeah, I guess the topic is really an edge topic for many of the audience, maybe also here, because the requirement, when you see a requirement for KubeVirt, I think it should be only in complex environments, right? Heterogeneous environments, enterprise environments. Like a startup most probably will not need it, but when your enterprise has a complex infrastructure, including external third-party vendors, in-house development, and some maybe like open source project, vendor supported projects, and some also appliances. So those type of complex environments needs also some solutions which you may apply your compliance for across through all your infrastructure. That may be one of the reasons it may not make sense for everyone. Sorry for this, guys. So if it doesn't make sense for you, but for if you have a complex environment, you'll need similar solutions or a likewise solution. My next question is, Bilal. As we are talking about enterprises, obviously enterprises needs support, maintenance, and also SLAs. So do you think this technology is enterprise grade? Because it's you mentioned open source. Does it also comply with enterprise requirements?
So, as I said in the beginning, this is a free and open source tool. So VMware is more mature and better tested for pure VM workloads. But KubeVirt is never, but it's growing fast. So, for example, Red Hat creates its own KubeVirt tool called OpenShift Virtualization. So if you want to, so if you are a enterprise, you can get KubeVirt support directly from Red Hat or from the other organizations also, because since they are managing their own KubeVirt version, in the end you will have a enterprise grade support from them. But I mean, you also mentioned that, but the way I see it, if you are already running Kubernetes and just need to bring some VM along for the ride, so KubeVirt makes a lot of sense. And let me add you just one more thing. But if your entire infrastructure is VM heavy with no Kubernetes inside, so VMware or the other tools is still a solid choice. It really depends on where you are headed as an organization.
Yeah, is OpenShift virtualization the only enterprise option? Does it also spread to other enterprise options in the market? So do we have one option or more options in the market, you think?
As of today, I know that it is the most viable option for KubeVirt, using the KubeVirt in an enterprise grade. The OpenShift virtualization is it's the more straightforward and most easiest way to start with. But so since this topic is a hype topic at the moment, I believe we will see most of the enterprise companies will invest in this area using KubeVirt, of course.
Okay, thank you. And for the audience who would like to see some hands-on experience, if you have any sandbox environment, if you can maybe share us some of how it looks like on CLI, that may give some maybe idea of to the audience how to administrate KubeVirt, if you have the sandbox environment ready, of course.
Yes, sure. For the demo, I created a cluster on AWS. It has 2 worker nodes, and now I will show you how I can. In that time, I will try to show you guys. I will deploy a pod. I'll deploy a virtual machine, and inside of that virtual machine, I'll try to communicate with the other pod. The other pod will be a Nginx pod, so we will try to hit the port 80 of it. So hopefully, in the end, we will see that Nginx default page. So what will this shows us? We will be able to see that we are running a pod and virtual machine inside within the same cluster using the same network, and they can talk to each other.
Yeah, don't worry, Bilal. All demos have blue screens.
Yeah.
that's the Murphy, right? That's okay.
And for the audience, as Chloe, we have created a public repository. I will try to find it and share it with the chat. So in that repository, we try to show how you can deploy a KubeVirt environment on AWS using bare metal instances, using also AWS FSx as a storage backend. So it has a bunch of CloudFormation stacks and all the YAML files you need while deploying it. It might be a hard to start with, but I try to explain everything in the README file. So I will also try to share it after the demo. Okay, so let me first try to. Sorry. Okay, I'll try to share my screen. Is it visible now?
Yes, we can see.
Okay. So let's show you what I have now. So as you can see here, this is a basic Kubernetes environment. I have 2 worker nodes, 3 master nodes, control plane nodes. These 2 worker nodes, their type is C5 metal. So these are the bare metal instances. To one of them, we will deploy a virtual machine. So let me clear it. I also deployed a pod here. It is a basic Nginx pod. I also expose it using a Kubernetes service. So now I will try to deploy a VM using a YAML file. So let's see the YAML file. So this is the YAML file I'll be using. See, this is what I was talking about. the kind is it's a virtual machine, and the API version is coming from the KubeVirt. So with the virtual machine kind, I'm telling Kubernetes that this is a VM that I'm deploying. I can give it a name. It will be a demo VM here. So when I deploy this, it will be its state will be a running. So I will directly start running KubeVirt directly start running it. Here I can give some interfaces, resources like memory, CPU, and I can also give some different network definitions. Now here, I'm saying that this will be a Fedora VM. So here I'm basically giving a container disk. This is where the Fedora boot disk will come from. And also here I give another volume, which is Cloud Init. So in the Cloud Init, I have a basic explanation. I have a user, I have a password, which I will be using while SSH into the machine. So now let's go and try to deploy it. Like I do like I deploy a pod, I'll use this YAML file to deploy it. So using the virtctl command, I can also SSH into it. So let's try to see what's going on with our new VM. It is now provisioning on one of the workloads. Okay, now we see that it is booting up. In a second, we will see that it is asking for a login. Okay, in another tab, I'll try to show you what happened on the cluster when I apply that YAML file. See, this is the actual VM that we just deployed. So as you can see, this is a pod, but our VM is running inside of it, alongside with our Nginx pod. So now I'll go and try to reach from this VM to the Nginx pod. Let's go, and it will be a curl command. Let me show you the services also. See, this is the services I have, Nginx SVC. I'll try to hit this service from my VM. So our login is defined in the Cloud Init disk. Let me clear it. So let's try to send this curl command. Okay. As you can see, I run a curl command. It's basically hit the other ports, port 80. So this is how it actually looks like if you run your VMs alongside with your containers.
Yeah, looks really impressive. So, of course, this is a use case for maybe Linux dependent appliances, Linux dependent maybe technologies that restricts you to maybe run on containers. But one other use cases I see also in the industry, maybe Windows also, right? Because Windows, I know Windows, or industry knows Windows supports containers now, for not now, for a long time, of course, but still companies are a bit skeptical to move their Windows to containers. But for Windows, do you think that may be a right solution as well? Did you experience Windows also running inside KubeVirt, inside Kubernetes?
Sure. If you are brave enough, you can run everything in KubeVirt. So yeah, you can also run Windows VMs using KubeVirt also. But,
okay.
You know, it has its own problems running Windows VMs. So it's basically, as I said, how brave are you?
Is it supported? Is it enterprise grade supported, Windows VMs also?
I mean, we need to explain a little bit what do you mean by the enterprise supported? Because using KubeVirt you can deploy Windows VMs, but if you are using KubeVirt, there's no support that you will enterprise grade support that you will get from them, since it is a community-based project. And
yeah, I mean, if you use enterprise solutions of KubeVirt, I mean, if it is supported.
Exactly, you will get support for any type of workloads that you run using KubeVirt. Like it can be also Oracle VMs, Oracle databases, or Windows virtual machines.
Yeah, because some of the applications also sometimes I'm dealing with have dependencies on Windows. That still happens, and no way to migrate them away from Windows. Most of the, I'm not mentioning about the standard .NET framework for X, but there are still some applications still depend on Windows. That's maybe still in the that is still in the industry. That's why I am asking. Okay, nice to hear this thing.
I mean, to add just one more thing. Honestly, it works. I mean, you can run Windows VMs in using KubeVirt, but it is not the smoothest experience compared to running Linux VMs on KubeVirt.
Okay. Is there any questions, by the way? I'm also asking to audience. If you have any questions, we can see them straightforward in the comments. Don't hesitate. We'll be finishing soon the webinar. Obviously, there are a lot of questions around this technology, maybe on what type of use cases it fits, or does enterprises still need this technology? So there are, we have mentioned till now mostly the technological or technical reasons, but one of the reasons is, and the topic of this webinar is alternative VMware exit. So do you think, Bilal, a VMware company, depends on VMware, can fully migrate from VMware to KubeVirt?
Yes, they can. I mean, there are even tools that can help you during this transition. Like there are three perspectives when I think about the migrating from VMware to the KubeVirt. So first one is networking. The second one is storage. And the last one is the infrastructure. So infrastructure is almost will be the same. It will be identical because you will have your same bare metal hosts. But the networking part is crucial because, as I said in the beginning, for VMware users, they do some hacky tricks to expose these VMs to talk to let the other workloads talk to the VMs. So with the new infrastructure, with the KubeVirt or with the overlay networking, can you also do the same? This is another question regarding networking. For the storage part, this can be also identical because you can use there are lots of enterprise grade CSI drivers like NetApp on Tap or the Dell EMC. You can have these CSI driver in your Kubernetes environment, and you don't even need to change the storage backend. So you can still use the storage backend as you do in the VMware. So if you completed all these prerequisites, it is really straightforward to migrate your workloads from VMware to KubeVirt.
Thank you, Bilal. So before we close the webinar, we finish the session. Let's see questions. There is one question from Doğan Ayıldız. Since KubeVirt wraps VMs in pods, does the extra layer add significant context switching overhead compared to bare metal ESXi, especially high I/O workloads? Is it safe for HPC? This is the question. Any comment? Do you have any comment on this?
Yeah, okay. Good question. So yes, there is some overhead because you are running a VM inside a pod inside Kubernetes. So that there is an extra layer compared to the bare metal ESXi, where the hypervisor talks almost directly to the hardware. But for most typical workloads, the overhead is minimal. We are talking single digits percentage performance difference. I mean, KubeVirt uses KVM under the hood, which is pretty mature and efficient hypervisor. So for the general purpose stuff, you're totally fine. But in your question, you mentioned that for the high IO workloads, like heavy database operations or network intensive applications, you might feel it. The good news is you can also use like things like SRIOV for network pass-through or PCI pass-through for direct hardware access, which basically eliminates that extra layer for IO.
Okay, so what you say is, Bilal, do you see that databases, did you experience databases are also running inside KubeVirt? Any database, doesn't matter.
Yeah. We did that before, and it was running fine. I mean, it's totally based on the like infrastructure and storage and network components that you have. So these are not coming directly from KubeVirt, so you need to deploy them yourself. So there are some difference between these CNI, CSI. So it can all these components can affect the running it smoothly, running a database on KubeVirt or Kubernetes directly.
Okay, so what you say is it is possible you have experienced databases, but it depends on of course, the storage, what storage you are using, what type of storage, what type of
Exactly.
storage system, storage technology, what type of network interface, which network CNI you are using. So it depends on not just KubeVirt, but more on those technologies, from what I understand.
That's correct, yeah.
Okay, we have one second question. Can we set a static IP to the VM? Do you know how to access the VM besides using virtctl command? Also, what do you think is the best CNI to use?
Good question. Yeah, so static IP, yes, you can. I mean, you can use Cloud Init to set a static IP, or if you are using a Maltus with a secondary network, you can assign a static IP through the network attachment definition. With Maltus, you get way more control over networking, so that's different than the overlay network. So that's usually the way that to go if you need a static IPs for your VMs. So static IP, to summarize it, yes, you can do it. Accessing the VM besides virtctl, you can. I mean, since this is a pod, you can expose it as a Kubernetes service, just like you would a pod. And so you can also create a node port or load balancer to access to that VM. It can be over RDP or SSH directly into it. So kubectl port forward is another method. But if you are using a different version of the KubeVirt, which is OpenShift virtualization, let's talk about OpenShift virtualization, you will have a graphical user interface. On your OpenShift console, you will see a virtual machines tab, and through that tab, you will be able to see all the virtual machines. You can also even connect to them, SSH into them, using your browser. So accessing the VM besides virtctl, there are few options. For the best CNI for KubeVirt, so honestly, my choice will be Cilium, because we faced with some issues running, networking issues running a KubeVirt on AWS. Because on the public clouds, it doesn't matter if it's a AWS or Google Cloud or anything else, they don't give you direct access to the layer 2 network. So in order to announce your virtual machines to the outside of the Kubernetes cluster, you need to have a CNI that supports it. So as of today, Cilium solved this problem using directly talking to the AWS API So let's say you have a worker node with C5 metal. If you want to have a dedicated IP address that announces to the layer 2 network of AWS, Cilium gets an IP from the network card and assign it to the VM. So from the EC2 instance you have, you can directly ping your virtual machines inside the same VPC. So my choice will be Cilium for sure.
Yeah, it has also other advantages, right, Bilal, like enforce MTLS between VMs. So you may also Cilium for additional security, not just for announcing, but have additional and integration with AWS also natively. So different advantages. Yes.
Exactly. Yes. Exactly.
Okay. Thank you, Bilal, for your comments, and thanks for everyone to join. If you have any comments, you can find us on internet.
Okay.
Anytime you can ping us if you have any questions.
I will also, just a second before we close it, I will also try to share the repository I was talking about.
Oh yeah, please.
Lots of repositories here. Okay, this one is the public one. With the following, I don't know how I can share it. Dorian, I will send it to you so you can share it with them.
Just comment or send it to me, that's okay. Or you can just type it.
I just sent it to you through Slack.
Yeah, that's okay. So for the repository that Bilal is mentioning, I'm now posting it into the chat. You'll see it. So if you want to try it out, yeah, use it. In case there are any issues on this repository, open issue, we'll be happy to see your issues.
Yeah, it might be outdated, so I'm waiting for your issues or pull request.
Yeah, thank you everyone for joining. Thank you, Bilal, for your time also. Have a great rest of your day, everyone.
Bye-bye. Thanks everyone. Thanks for listening.